And actually, for us, most of these guys, like you can see the thing here, most of these guys are actually, most of our customers are streaming the telemetry data of the cluster, and we actually host just the UI portion. Our agents are obviously on the cluster, but most of this is actually we host this. So it's by definition a different cluster because it's on a different site. Yeah.
Sorry. So you always analyze the job history, but I guess, but are you also looking for solution online where predicting or like analyzing if something can go wrong as soon as you see some anomaly in the job, and then you can predict that this might cause problems?
Yes. No. We definitely do that.
Rather than solving the problem, don't create the problem.
Right. So this presentation was oriented towards, again, not pitching our product. I know I'm getting into that, but this presentation was just about things that go wrong with Hadoop clusters and what the root causes are. But in active mode, like shortly after, this one here, this was a POC at the time, and they saw this issue, and then, the resolution here was they turned us on, right? So the solution here was absolutely to turn on the Pepper Data product, and it prevented the issues. Right, we prevent the disk thrashing, we prevent the node from getting overwhelmed, and it's completely proactive.
You don't want to tell how? You don't want to tell how do you do that?
Well, I mean, it's too long of a technical discussion to get all into it, but I can give you the rough. I mean, we're watching everything that's going on. So when we see, the RAM is a little different, but if this was, some kind of bandwidth, is this CPU use or network use or IOPS use or whatever, and these guys were over the capacity of the system in any given second, we'll reach into the lower priority guy and we'll say, you don't get to go so fast. Yeah.
Tell a story about diagnosing something other than misbehavior of a user, like say network segmentation, or you're in a cloud and you've got a noisy neighbor.
Yeah. I'll give you one which it was absolutely the right behavior. This is a story from before Pepper did, actually. This is a story from Yahoo. So, and this is not quite the first version of Hadoop where, we were happy if it stayed up. This was a few months in. So we were running a cluster, we had a Hadoop cluster, this was in search. And somebody was doing a bunch of work on the Hadoop, entirely reasonable work. It was good stuff to be doing. It was somebody on the team, and I wanted them to be doing this work. They ran a job that had a very expensive shuffle. Basically, it was a very expensive network transfer. And it was entirely reasonable to do this. They were basically trying to, this was our first use of Hadoop was the web map process, where we were trying to do graph processing of every link on the web. And so there was this very expensive shuffle, and it was trying to transfer a huge amount of data over the network, and basically that shuffle saturated the network. And that was fine. Hadoop is designed to allow you to saturate your hardware resource, and so it saturated the network. Good. And this was, at the time, this was before 10 gigabit network, so we had 1 gigabit network. So it saturated, and it was basically the core switch that was getting saturated here, and so the core got completely saturated. And that was from that job, and Hadoop good, met the goal. Unfortunately, the search engine was also on this core. And so basically we had a sustained, persistent outage of the search engine that was on the same core. And so a whole bunch of guys from the search engine floor, this is we were the one building at Yahoo, and a whole bunch of guys from the search engine floor went down one floor to the guys from the Hadoop floor and said, what are you doing? And as soon as we figured out what the cause of the saturation was. And the interesting thing in this case was it wasn't misbehaving of Hadoop. It was supposed to do that. And the other interesting thing was the magnitudes involved. So the search engine was really important traffic, but it was really small. It only needed about 50 megabits or so to do all of its queries and responses. And Hadoop was sitting here chewing up a gigabit for 15 minutes. Now, if Hadoop was using 950 megabits for 16 minutes, nobody would have cared. Like the Hadoop guy wouldn't have cared at all. But the fact that it had no way to not use all of it pretty much took down the entire search engine. This was search.yahoo.com, right? The main web results. It took it down for 15 minutes, and that was pretty bad. So that was,
So I'm curious, other ones you describe your diagnostic steps and, we looked here and then we found this other, and so you clearly didn't have this marvelous pep data thing.
No. Oh, so how did we find it out? So in that case, what happened?
Nagios was screaming about your core switch, or?
No, I wish. This was many years ago. We were less sophisticated then. I think eventually we got a Nagios alert, but I think that was on like 10-minute boundaries or something crazy like that. What happened was we saw that we knew the search engine was down. Like 10 seconds after we weren't getting queries, we knew, right? The pagers went off.
Yeah.
But we knew. I think we rapidly went into, we logged in, it was a lot of logging into nodes at this point. So we log into the search, like we see the traffic's not there, we log into a node and we say, okay, well, is the log moving? Okay, it's not outputting any more log. Okay, what's going on with that? Okay, is it getting any queries? Well, it's not getting any queries. That's really weird. Let's log into this one. Hey, it took a long time to log into that node. Why did it take a long time to log into that node? What's different about this node than the other node? Oh, it's across the core switch. Oh, so it was extremely manual, and that's why it took us like it took us the better part of the 15 minutes to figure out what the heck was going on when this happened. It was basically logging on nodes and rapid, deciding that, oh wait, it's not a software bug, this is a network bug. And we thought the core switch we couldn't figure out why the core switch was having this trouble, and then we finally looked at the graphs of the core switch after we got the idea that the network bug was like, oh, it's completely saturated. And that led us into, okay, well, let's log into the core switch. Let's see where its traffic's coming from. And then, so you log into the core switch and you see where its traffic's coming from. You say, oh, it's this IP range here. And so let's look, what's in that IP range? Oh, that's the Hadoop cluster. And so it was there when you're not looking at all this data at the source of the data. Basically, the name of the game is hop from point A to point B to point C until you actually see it. And in retrospect, telling the story, it reminds me of like the hackers in TV shows when they're like, I'm 3 servers away and I'm finally getting there. It didn't seem so glamorous at the time. We were kind of panicked. You had another question?
Yeah, a couple of questions actually.
Yeah.
So one is just on this topic. So right now, you mentioned you saw that 6 GB, 8 GB, whatever you were running into memory conversion, right? So in general, you might be having a lot of customers, big customers. So what is the big pressure point, like memory, network, or disk? Originally, the hard disk was the thing. But
We've seen every single one. And we see all the different ones at different points in time.
Okay.
So one cluster frequently across the cluster has different pressure points at different points in time. So
it's
it's
a more general one. I'm just trying to understand what is still the pain point,
what do we see more than anything else? I guess what we see more than anything else is we see things that are limited by kind of an artificial resource. We see things that are limited by slots. Right? Just because people had to be conservative in terms of how many slots they configured, which is kind of silly because when you go and buy a bunch of Dell servers, did you order them with 8 slots?
But Yarn is going to help, I guess.
Probably, maybe a little. But it's still pre-allocation, right? Yarn is still pre-allocating things. You no longer have slots, but you pre-allocate RAM. So I'm kind of hoping, theoretically, Yarn might help you fill up the RAM a little bit better.
At least you're not, not just maps of it.
Yeah, so Yarn's definitely going to help with that. The thing that's very exciting about Yarn, I'm very excited about it, is it's going to let you put other things on the cluster. So I don't know how Hadoopy this crowd is, but Yarn is the replacement for MapReduce, and the way I put it is, if Hadoop is a highway, in MapReduce, the first version, MapReduce and the job tracker lets you put trucks on the highway, and lets you put a lot of trucks on the highway, and you always know the trucks will get to where you want, and that's great, because it's hard. And what Yarn lets you do is you put anything on the highway. And you can put trucks and motorcycles and cars and donkeys and whatever you want to put. Yarn will let you put it on, but it's still, the MapReduce and Yarn are always the metering lights. They're basically saying what you can put on the cluster, but once they get it on the highway, they don't. It puts the thing on the cluster, and once it's there, it's like, I don't know what it's doing.
Yeah, the next question is, so, like, when you're controlling proactively or whatever, isn't it going to, hamper or interfere with the schedule or so?
No. So the schedule.
Execution and those type of things.
No, we have to pay attention to that kind of thing. It doesn't because it does require the user to tell us what's important. The user has to say this is important or this is not important. But once that's true, it turns out that the number of points in which guys stomp on each other for a given resource is actually relatively few and far between. Reviewed by the cluster, it's always happening somewhere, and it's always raining somewhere in the world. There's always something stomping on something else somewhere in the cluster, right? And so the net effect of this is that high priority jobs have huge variance in runtimes, like 15 minutes, 3 hours. But as viewed from the low priority ad hoc work that's interfering, it's not most of the time that they're interfering, right? And so you can actually have a very deft touch. You can actually say right here, affected right here, and right here, affected right here, and the net effect on the low priority guys is pretty small. We don't see like huge swings in speculative execution or anything like that, because it's relatively few and far between you have to touch it.
Okay.
That was the question. Yeah.
So my question is kind of related to the yarn
Yeah.
discussion there, because we use Impala on top of everything, just to add an extra dimension.
Yeah.
And it's wonderful. But
It's very exciting about Hadoop. It's letting people do all this kind of thing. That's why I'm so excited about Yarn too, because it'll let more of that happen.
But one of the problems we've had is the transient bumping into each other. Our Hive jobs bumping into, our MapReduce jobs bumping into Impala with ad hoc queries.
Mhm.
And it's been very difficult to kind of get things tuned so, and just manage. And the belief is that Yarn will help with that.
Yeah, Impala is moving to Yarn too.
Yeah,
on top of
with
Yarn.
5.0, but in the CDH, but
Well, I don't know. I don't want to take anything away from Yarn because it's a great thing for the ecosystem and it's great what all my former Yahoo colleagues have done with that. It's fantastic, and it might help some, but depending on the cause of the bumping into each other, it may or may not fully solve the problem, right? Unless you actually are looking at the data and seeing what's going on, it's hard because you either have to be, it's kind of the difference between pre-reservation, which is what all the schedulers do, and dealing with what's happening in decontending when there's actual overbooking. When you have to pre-reserve, you tend to have to be very conservative, right? You have to guarantee that, hey, I can't ever get overbooked, because if you get overbooked, like, for example, if you get overbooked on RAM, you're screwed. If you get overbooked on network, you're screwed, because heartbeats can't get through, data nodes can't talk to each other, you're done. And so you just can't let those resources get overbooked, so you pretty much have to be conservative. And so that's, so you won't ever run those resources up to the limit. If you're not limited by those resources, maybe you are fine doing all pre-reservation, but that would be kind of an unusual situation. I should use another analogy. It's like the airplanes, right? They can keep themselves fully booked because they overbook themselves and they have a way to decontend. They kick people out of their seats. Be nicer. I like our method better, where we can just kind of pack people in a little more nicely. But if you have a seat, then you have to kick people. So I think in certain types of workloads, Yarn may solve the thing. And you should definitely, I'm really glad that Impala is moving themselves to be on top of Yarn, because it's much better than them laying a daemon out separately. So it's a huge step forward. But I suspect, based upon what we've already seen, that you'll still have this problem. And this is a useful thing that is kind of orthogonal to what Yarn does. Yarn is getting lots of trucks and cars and donkeys and everything onto the cluster, and that's what it does, and that's what it's designed for, and it's good at that. But dealing with the real-time effect of it is not what it's designed to do, and that's okay. It's just not supposed to do that.
There's a little bit of that, right, in general, preemption is there.
Yes, there is a little bit of that. There is preemption, and there's preemption in the pre-yarn, there's preemption in the post-yarn, and that's a pretty severe reaction because you lose work then, and so we try to avoid that. Yeah, because that's a pretty severe thing. Preempting, if you preempt the task and you stop it running, then you lose all the state, and that's pretty painful. Because then you've net lost cluster capacity because you wasted it all on that thing that you stopped. And pretty much what you really want is you want to preempt as little as possible. You want to preempt as little as possible. You want to speculate as little as possible, as long as you can guarantee latency. And it's actually, I don't know this, but I wonder if stabilizing the latency of high priority jobs may lead to less speculation. Because the way speculation works, it's how many deviations are, if you've more than so many standard deviations away of the runtime, then you start speculating. If you stabilize the latency, you may not actually see that as much. But I don't know that to be true. All right.
I have a question. This is specific on the yard. We're in the process of moving to basically going from CH3 to CH5.
Good.
So my question is regarding, again, it's all slots, right?
Mhm.
So in Yarn, basically the code generates an application and then pushes it over. And if I'm not mistaken, it's allocating a slot to just do that job, basically, like for TIG jobs, right? So that's an extra slot.
It is. It's not really.
Can you briefly repeat the question?
Oh yeah, the question was in Yarn. The understanding, which is correct, is that when you're running a MapReduce job, the master is effectively another thing that runs on the cluster. It's not separated out in the job tracker the way that the pre-Yarn was. And so does that consume another slot? And the answer is roughly yes, it does, except that Yarn doesn't call it a slot. It's a container, and Yarn doesn't necessarily have a fixed number of slots. It has a fixed quantized buckets of virtual memory, which, since they're quantized, are actually pretty close to slots, but they're not called that. So it's actually it's actually pretty darn close to slots, but they're not called that. They're containers now. But it's still better because you really want the authors to express it in terms of virtual memory. But it is absolutely taking a slot, but that's probably a net win because you take that compute and that RAM pressure away from the job tracker. And so it's probably a net win for the cluster to have that distributed throughout the cluster so that you don't have the job tracker using it.
But that just from my own personal point of view, that actually helps if you have multiple Yarn hosts, right? As opposed to, having a single host. The cluster is not big enough, let's say 100 or so nodes, right? So you kind of say, okay, I'm gonna have this Yarn thing,
Mhm.
which is almost a one-to-one replacement for the previous job tracker.
Mm-hmm. So the question you're asking if you had a very small cluster, would this movement of some of the responsibility from the job tracker into the cluster, would that potentially be a negative? It could potentially be a negative, but I suspect that your cluster would have to be really small, right? Like 2 nodes. For 1 node, it probably doesn't matter because, well, it was on the job tracker, it's on that node, and it's a task, a separate process is on that node, it's on the node. If you had 2 nodes, then maybe you don't get to balance the work, you don't get to fully utilize the second node. My guess is once you're at like 6 nodes, you're not gonna notice. Right, it does depend on, you may have to do a whole bunch, and again, this is the difference between the pre-reservation and the active control, right? So when we're managing a cluster, you know, when we're actively optimizing a cluster, we'll look at how much memory every single thing is actually using and stuff more in if it can fit. That's for memory limitation things. If you're pre-reserving, you may have to pay attention and tweak how much you let that app master think it's going to use. Because if you've got a very small cluster, it may not need much virtual memory. And so you could get some benefits if you like study and tweak what's going on.
The motivation for Yarn is actually to use it for bigger cluster, not a smaller cluster. Even 100 node cluster is not an ideal place for Yarn.
Yeah, but I think everybody's going to move to it anyway.
Well, that's
Yeah.
the case, but
Yeah.
but I guess in that case it could be a problem that Yarn might not.
It may not be quite optimal.
Yeah.
If you were doing real-time control, it actually doesn't matter. It'll be optimal either way. But it's you can construct a case in which it might not be optimal, and that construction of the case is much easier if it's a smaller cluster. If it's a big cluster, then the performance effectiveness of Yarn of moving the app master out into the side is a huge win. But the main thing of Yarn that I'm so excited about is to let you work different kinds of workloads on the cluster, right? Like you get Impala is not this odd mismatch, and you can lay out Spark on the same cluster, and you can lay out Storm and Data Torrent and HBase and Hoya, and you can lay all these things out on the cluster, and that's great. I'm very excited that Hadoop is going to be a multi-use appliance that way.
Final question.
Seems, yeah.
So
I'll
like,
repeat it.
the distributions, like obviously, many of them are lacking any of these features, but probably the Cloudera has some better manageability features, right?
Not really. So we do all the we do all the distributions. We
Okay.
run with all Cloudera, Cloudera, Hortonworks, Pivotal, IBM, MapR. We do all of them. Cloudera Manager does a really good job of surfacing the data Hadoop knows. So it's got a really good job, and Ambari's catching up. But Cloudera Manager, like the data that Hadoop knows, like the job counter data and all that, and putting some pretty like extracting some data out of Ganglia and putting it in there.
Yeah,
really
that's
good
what
way.
yeah.
They're really good at that, and they have a very pretty UI on that.
You
But
don't
it's
see
still
them competing with you.
no.
Catching up.
We're a partner with them.
Probably.
What they do is the data that Hadoop knows, and what we do is different data, and so they're complementary.
Okay.
And Cloudera Manager is not trying to change the state of the cluster every second. It's not built to do that. It's not its job. It helps you get the cluster running, and that's good because it's hard.
Great.
All right.
Please join me in thanking Sean. Come and chat with him if you want to know more about Pepper
one more
data.
thing. I forgot I had one more slide. We have a meetup tomorrow too.
Oh.
Totally different audience than yours, so I don't think we're going to be competing. This is going to be, so our meetup is very focused on the Hadoop, more, I showed some war stories here. These guys will have more than me, I guarantee. So if you're interested in war stories, come by. Alan Wittenauer, Hadoop operator, at large from LinkedIn and other, and Yahoo. Eric 14, kind of he likes to call himself the midwife of Hadoop. And Todd Nevitt, SE extraordinaire formerly from Cloudera. Tomorrow, downtown Sunnyvale, you can see it there, meetup.com/pepperdata. So if you're interested in the very low level stuff, and you don't want mobile social, probably a different crowd, I hope I'm not taking away from that, then, there's this.
Please do.
Sorry.
Thank you.
Make sure to read Sean's blog post also on our
Yes.
website, www.hypedata.com. Thank you.
Thank you.
I saw Nigel.
I saw Nigel there in the back a second ago.
Yeah,
There you go.
Nigel,
There
why
you
you
are.
sitting? Why
I
you
didn't
back
see
benching?
you at the beginning, and then I saw you sitting right
Yeah.
there.
He was probably late.
Thank you so much. Thanks.
You did a very nice presentation.
Thank you.
I believe in we went for CH1. You are.
CH3 is a very good product. We've installed posters with every single product.
Il explique bien. Ouais, ça marche bien. Il est très didactique.